Who's that? Okay, chapter 1 is all about functions and graphs. So, section 1.1, which we will, I think, split into 2 days, is about modeling and solving equations. Okay, so we're going to look at numeric models, algebraic models, graphic models, what the zero factor property is in problem solving. Okay? All right. Why? Because these models provide different methods to look and understand data. A mathematical model is a model that approximates phenomena for the purpose of studying and predicting behavior. Don't worry about taking notes on this. You do not need to know the difference between a mathematical model and a numeric model and that. A numeric model is a kind of mathematical model in which numbers are analyzed to gain insights. And an algebraic model uses formulas to relate variable quantities associated with each other. So a model is just something we look to observe data, like population growth of my fish in the fish tank, or population growth of my snails in the fish tank. Okay, we're going to look at that possibly this year. Depends on how our numbers are working. Okay, so a numeric model just uses numbers, and then an algebraic model uses variables for it. Okay, so a pizzeria sells rectangular 18-inch by 24-inch pizzas as at the same price it sells a large round pizza, which is 24 inches in diameter. If they're both the same thickness, what is the best pizza for the money? Well, if you look at it, well, you want to find the area of each pizza. Geometry has provided algebraic models that allow us to compute the area. Okay, so the area formulas are over there on that side of the room. Okay, 18 by 24, how do you find the area? Multiply those two numbers. What's 18 times 24? 432. Okay, how do we find the area of a round pizza with a 24-inch diameter? Now, area is pi r squared, right? Do they give you r? No, they give you the diameter. What's the radius? 12. So you take 12 squared times pi. What's 12 squared times pi? 452.39. So what's bigger? The round one. Okay? So the round one gives you more for your money. The 432 versus the 452, well, 452 is better. Okay? Graphical model is using graphs to visualize what's going on in a situation. The zero factor property, the product of real numbers is zero if and only if one of them is zero. So that's where, a graph would cross the x-axis is zero. Okay? If you solve an equation like this, okay, you set it equal to zero, find what x's are. Okay? That's part of the zero product property. Well, that doesn't factor, so you have to use a quadratic formula. Remember the quadratic formula? Everybody knows how to sing the quadratic formula song, right? Negative b plus or minus the square root of b squared minus 4ac all over 2a. Okay, so we remember it. We're going to all sing this together. All right, the quadratic formula song. Everybody's going to sing. Don't be embarrassed. We can all sing. Ready? Negative b plus or minus the square root of b squared minus 4ac all over 2a. All right, So they had x squared equals 8 minus 4x. You put them in order on the left side of the equation. A is the coefficient of this, B is this coefficient, C is this coefficient. They plugged them into the formula. They used their calculator to help them out to get negative 5.46 and 1.46. Okay, so at times we'll be using the quadratic formula to help us out. Okay, so a solution is where a function is equal to 0. Okay, where it crosses the x-axis. Okay, and so on. So an x-intercept is where it crosses. Four-step problem solving plan. Understand the problem, devise a plan, carry out the plan, and then figure it out. Okay, I don't think that's very important. Yeah, we'll call that good. Let me go to here. Boom, boom, boom. All right. So, when you get to your homework, you'll have problems like this, which say, match a numerical model to the corresponding algebraic model. Now, looking at this, 3, 6, 5, 10, 7, 14, 9, 18, what do you notice about the x numbers and the y numbers? They're getting bigger. How does y compare to x? Y is twice the x value. Okay? Y is twice the x value. So it consistently goes up by 2 on the x's and 4 on the y's. Okay? So everything's consistent. So if it's consistent, would it make a curve or a straight line? Straight line. Okay? As this goes up, this goes up. So as your independent variable increases, your dependent variable increases. So as x goes up, y goes up. It has to be graph B. Okay. Now, as Daniel explained, okay, the y's are always twice of the x. So that would be your equation. Okay. So, yeah, we'll call that good. So let's look at this one. 4, 7, 10, 13, 16, 19. These you're adding 3 to every time. 4, 10, 16, 22, 28, 34. These you're adding 6 to each time. Okay? Still is consistent. Okay? So if it's consistent, what we're doing each time, we have a straight line. Now looking at this graph, okay, which of these would make sense? Well, a square root function. Oh, I didn't want to do that. Undo, 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 undo. Okay. I don't want you highlighted. A square root function will look like that. A squared function will look like that. Okay. So, what does this tell you? The number in front of x is the what of the function from Algebra 2? Besides being the coefficient, the slope, y equals mx plus b. The coefficient of the x is the slope. This is a negative slope. This would go to this graph. So then a positive slope would be this one. Okay? So, understanding what you learned back in algebra. All right. Up by 3, up by 3, up by 3, up by 3, up by 3. Up by 33. Up by 51. Up by 69, and so on. Is that consistent? No. So it will make a curve of some kind. Okay? Now, this is a straight line. That doesn't work. This is a line that kind of leveled out. That doesn't work. This is a parabola. That could possibly work. This is a square root function. That isn't going to work. So I'd say the parabola would work. So if you take 4 squared, what's 4 squared? 16 plus 5 is 21. 7 squared is 49 plus 5 is 54, and so on. So this would be our function. Okay, so you'll have various ones where you have to look at that. All right, this one, the table below shows the percentage of males and females in a certain country, in a certain county, employed in the workforce in selected years between 1970 and 2005. According to the numerical model, what has been the trend in males joining the workforce since 1970? What has been the general trend? Slightly decreasing. There's a decreasing trend in males joining the workforce, except for a slight increase from 2000 to 2005. Okay, so you'll be answering questions about this type of thing. In what 5-year interval did the percentage of males who were employed change the most? So what's the biggest change? Well, the first one is about a little less than 3% change. Second one is a little less than 2. Third one is almost 4. Fourth one is 6 point something, it looks like. And then 2, and then 3, and then 2. So that 6 point something, 85 to 90, would be the biggest change. Okay? A garden shop sells 10 by 10 square stepping stones at the same price as 15-inch round stones. If all stepping stones are the same thickness, what gives you the most for the money? That's just like our pizza problem we did earlier. Ignoring air resistance. An object in free fall will fall d feet in t seconds, where d and t are related by the algebraic model of d equals 16 t squared. Okay? Little physics problem for you. How long will it take an object to fall 1,928 feet? Now, 1928, is that the t of the equation or the d of the equation? D for distance. So you would set up 1928 equal 16t squared. Okay? Now, how will we solve that equation? Don't take the square root yet. You could, and it'd be fine. Let's divide by 16 first. What's 1928 divided by 16?
120.5.
100 and what?
20.5.
Now take the square root. It, I would guess, is somewhere around 11. What? 10.9. Okay, round to the nearest tenth. 10.9 seconds. Okay. The second one, an object in free fall for 15.5 seconds. How tall was it before when it was dropped? Well, that's the t of it. So d equals 16 times 5 or 15.5 squared. So you take the 15.5, square that first, and then multiply the 16, and you solve it. Okay. An automobile company, rental company, charges $40 per day plus 10 cents per mile. She used the car for 1 day and drove 145 miles. How much did she pay? Okay. Well, let's set up a function for this. Let's set up an algebraic model. Okay. So the function is the cost per mile equals how much per mile? 10 cents per mile plus $40 a day. We could graph this if we wanted to because y equals mx plus b. But we don't have to graph it. We're just plugging in numbers. Okay? So she drove 145 miles. Take 10 cents times 145 miles, which is $14.5, right? $14.5 plus another $40 is $54.5. If she paid 73.20, you set the 73.20 equal to 0.10 m plus 40, and you solve. Okay? All right. So there are 10 problems that you'll have to do today. And that I think is all we're going to do today because I'm only going to cover one lesson instead of two. On Thursday in here, we'll do two lessons. Okay, one before lunch, one after lunch. Okay, but today we're just kind of easing you in a little bit, so we're just going to cover one. So I will go on to Math Excel for School. And I will put that out there for you. Assignment manager. Assign. And it should be out there.